Hello everyone, welcome back to the DSA series. Today we are going to be implementing a stock data structure using a linked list in C. Now if you guys don't know what is a stock, I made a video titled What is a linked list? I'll leave it as a link in the description. It will also pop up as a card on the screen as well. So if you guys don't know, we can also implement a stock using an array. So I'll leave a link in the description for that video I did on implementing a stock using an array. So let's start implementing a stock. So let's do vim stock.c. And we'll include our, let me just set the line numbering, and we'll include our standard input-output library.h. We'll also include our standard library.h. And let's define a structure for our stock. So we'll do a type def struct stock. And it will be a type of stock underscore t. We'll also define a structure for our linked list. So we'll do a type def struct. Let's just call it linked list. And then it will be of the type linked list underscore t. And it will contain a value. And it will also contain a structure of type linked list, which will be a pointer to our next node. And then inside of our stock structure, it will contain a list t pointer linked list, which will be our linked list that we'll use to implement our stock data structure. So let's start by creating a function that will allow us to create a new node for our linked list. So it will be of the type linked list t pointer. Let's just call it linked list underscore create node, and it will accept a int value, and it will have a linked list t pointer new node, and we'll allocate memory on the heap. So we'll do a malloc size of a linked list underscore t. And then we'll set our new node value equal to our value that we pass in, and then we'll need to set our next node equal to null. And then we'll just return our new node. So let's start defining our stock operations, guys. So if you guys don't know, a stock has three basic operations. So it has push, pop, and peek. So let's start by implementing our push operation. So we'll do a void stock underscore push, and it will accept a pointer to our stock, and it will accept a value that we want to push onto the stock. So in order to push a value, guys, we'll need to create a new node for our linked list, right? So we'll call our linked list underscore create node function, and we'll pass in our value. So this linked list inside of our stock structure, guys, it will essentially be the head of our linked list. So we'll need to overwrite this linked list, which will be our head, to make it point to our new node, and also our new node will point to the previous head of our linked list within our stock structure. So we'll essentially set our new node next equal to our stock linked list, and then we will set our stock linked list to point to our new node, and that should be our push operation. So let's implement our pop operation now. Let's do a void stock underscore pop. Wait, let's make it a bool. So we'll need to include our std bool.h, and we'll have a bool down here. We'll call it stock underscore pop, which will accept a stock t pointer stock, and it will also accept a int pointer, which will be the value that we pop off our stock. So in order to pop a value of our stock, we first need to ensure that our stock is not empty. So to check if our stock is empty, we'll say if not stock linked list. So if that pointer is equal to null, then we will just return false. At the end, we'll just do a return true right here. Now to pop off our stock, guys, let's see, all we need to do is just since we're insert, each time we push, we're essentially pushing the value at the head of our linked list. So therefore, we'll just need to we'll need to get the next value or the next node after our head, or the next nodes, right? So we'll need to save the next node. So we'll have a linked list t pointer. Let's just call it next node, and it will be equal to our stock linked list next, which will be our next node. And then we will need to overwrite, we'll need to free the current node. But before we do that, we'll need to initialize the value to be the value that we popped off the stock. So we'll dereference our value, and we'll set it equal to our stock linked list value. And then we'll get our next node, and then after we get our next node, we'll essentially free the head of our linked list. So we'll do a free stock linked list, and then we'll say stock linked list equals to our next node, and that is our pop operation. So now, guys, let's implement a destroy function, because since we're allocating memory on the heap using malloc, we'll need to free our memory for our stock as well. So let's create a void stock destroy function, which will accept a stock t pointer stock, and we'll essentially iterate through our linked list and free each nodes one by one. So we'll do a linked list underscore t pointer, and we'll say linked list equals to stock linked list, and then we'll do a while linked list. We'll then say free linked list. So that will essentially free our current node. But here's what we can do, guys. We can just save our current node right here. So we'll say linked list t pointer current equals to our linked list. Then we can set our linked list equal to our current next, which is our next node, then we free our current, and then that will be our destroy function. So let's test out our stack now, guys. So let's create our main function. We'll have a stack t right here. Stack, and we'll initialize it to null, and then we'll call stack underscore push percent stack. We'll push a value of 1, then we'll push a value of 2, then we'll push a value of 3, and then a value of 4. Now here's the thing with our destroy function, guys. We need to uninitialize our stack, right? So let's create a init function. So we'll do a void stack init function up here. Wait, let's do it down here instead. Void stack underscore init, which will accept a stack t pointer stack, and it will just set our stack linked list equal to null. So then now, guys, all we need to do in our destroy function is just do a stack init down here, and then we can just pass in our pointer to our stack. At the end right here, we can do a stack destroy percent stack. So let's try to pop a value of our stack. So we'll do a if stack underscore pop percent stack, and we'll need to have a popped value, and we'll do a printf popped value of the stack modulus d, new line, popped value, and let's define a popped value up here, and we'll initialize it to 0. So let's try to test out our stack now, guys. So let's compile our code. So let's do gcc stack.c -show stack, and let's execute our stack. So you guys can see it said pop the value of the stack 4. So you guys can see we inserted each value like this. We inserted 1, then 2, then 3, then 4, and 4 becomes the last value. So 4 is at the top of the stack. Oh, this shouldn't be off, it should be off. So let's actually implement another operation, guys, to print out our stack. So let's do a void stack print, and it will accept a stack t stack, and it will print out our stack for us. So we'll do a check up here. We'll say if not. So alright, sorry about that, guys. So we'll check if our stack is empty. So if our stack is empty, we'll say if not stack dot linked list. Then we'll do a printf the stack is empty. Let's just do stack is empty, new line, and then we'll just return. Otherwise, we'll do a while loop right here. Let's just define a linked list underscore t pointer linked list right here, and it will be equal to our stack linked list. We'll say while our linked list, then we'll essentially do a printf modulus d new line linked list volume, and then we'll set our linked list equals to our linked list next. Let's do a printf up here, and we'll say the values in the stack are, we'll do a new line. So So now let's test out our stock print function, guys. So we can do a stock underscore print stock up here, and let's recompile our code. Alright, so we have an error at line 47. Let's see what is that. At line 47, so this should be stock.linklist. And let's recompile our code and then let's execute it. So you guys can see it says the values in the stock are 4, then 3, then 2, then 1. Right? So our stock is working properly. So let's try to wrap this in a loop now, guys, to show that our stock is working properly. So we'll do a size t old size up here, and we'll set it equal to our well, let's not do that. So we inserted 4 items within our linked list. So what we'll do, we'll say, since this is a linked list, guys, we can't just check the size of our stock. We'll need to do a while linked list. Then we'll try to print out our stock, then we'll pop a value of our stock. So now we can try to execute our stock, and you guys can see it prints out the values of the stock 4, 3, 2, 1. Then it popped the value 4 of the stock. Then the values in the stock are now 3, then 2, then 1. Then it popped the value 3 of the stock. Then the values in the stock are now 2, then 1. Then it popped the value of the stock 2. Then the values now become 1. Then it popped the value of the stock 1. Alright, so it didn't print out that our stock is empty. That's because we need to do a stock underscore print stock down here. So we can execute our stock now, guys, and you can see it said it popped the value 1 of the stock, and then the stock is empty, right? So it's actually working properly. So let's implement one last operation for our stock, guys. We'll implement a peak operation, which will essentially give us the value at the top of the stock. So we'll have a bool stock underscore peak, and it will accept a stock t stock, and it will essentially return a value the value at the top of the stock. So we'll need to first check if our stock is empty. So we'll say if not stock dot linked list, then we'll just return false, which means our stock is empty. Otherwise, we'll just do a return true. Now, guys, to get the value at the top of the stock, all we need to do is just set the reference or value that we pass in as a parameter. Right, so that pointer, and then we'll set it equal to our stock.linked list value, and that will be our peak operation. So let's test out our peak operation. So we can just do a print, a checkup here. We can say if stock underscore peak will pass in our stock, and we'll pass in a peak to value right here, and then we'll say, yeah, let's move this above here outside of our loop, and we'll define a peak to value up here. We'll initialize it to 0, and then we will do a printf the peak to value at the top of the stock is modulus d, new line, and then we'll just print out that peak to value. And yeah, let's decrease this right here a little bit. We'll just do the peak value is modulus d, and let's recompile our code. So let's execute it now. Alright, so you guys can see it said the peak to value is 4. Then it printed out the stack, and then at the top of the stack we have 3, 4, then we have 3, then we have 2, then we have 1. And then it popped the value 4, so now the peak value becomes 3. Then the values in the stack are now 3, then 2, then 1. Then it popped the value 3, so now the peak value now becomes 2. Then the values in the stack are now 2 and then 1. Then it popped the value 2 off the stack, then the peak value now becomes 1. Then the values in the stack are now 1. Then it popped the value 1 off the stack, then the stack becomes empty. Alright, so that will be it for this episode, guys. Please don't forget to hit the like and subscribe button, and I'll see you in the next DSA video.